Air can be separated into oxygen, nitrogen and argon by fractional distillation. Oxygen is used in a number of chemical processes, including steel making and metal cutting. Nitrogen gas is used as an inert atmosphere for storing food. Argon is used for filling light bulbs. Air, the raw material for this process, is everywhere, and so plants are sited for the convenience of distributing the products. The principle of the process is straightforward. Air is cooled until it becomes liquid. Nitrogen has a lower boiling point than oxygen, so it rises as a gas up the distillation column. Liquid oxygen collects at the bottom. On this side, air is drawn in and compressed at this point. The air is cleaned. After further compression, it's fed into the distillation column as a liquid. The liquid air products are stored on the site before delivery to customers. Air is the raw material of the process. It is drawn in here and then drawn through filters to remove dust. The filtered air is then compressed, and this powerful compressor forces the gas stream through the process. The air is chilled to 6 degrees Celsius. Most of the moisture condenses out. The cooled air passes through chemicals which absorb the carbon dioxide and any remaining water. Further cooling takes place in a heat exchanger using cold gases from the distillation column. The air is cooled even more by compression followed by expansion. The energy from the expanding gas spins a turbine, and that in turn provides some of the energy for the compressors. Final cooling takes place here. Eventually, the liquid air is led into the fractional distillation column. This tall fractional distillation column is in fact 2 columns, with a low-pressure unit sitting on top of a high-pressure one. The double column works like this. Air enters the high-pressure column as a liquid. Nitrogen boils off and rises as a gas to the top of the column, where it's condensed. A liquid rich in oxygen condenses at the bottom of the column. The oxygen-rich liquid is fed to the low-pressure column. Any nitrogen boils off and almost pure liquid oxygen condenses. Argon is separated as a byproduct from the oxygen-rich liquid, in a side column by further fractional distillation. Small quantities of gases can be supplied to customers in cylinders. Larger quantities of air products are supplied as liquids in refrigerated tankers.